Welcome. In this video, we're going to go over a whole bunch of problems from our most recent homework packet, and I hope that this is helpful. Let's not waste any more time, and let's start right with the first problem. So the first problem is a binomial setting because you have like a success or a failure. You have a red light or a green light. And when we do this, of course, we're thinking, what is the number of trials? What is the number of successes that we're looking for? What is the probability of success? And what is the probability of failure? And so what happens? Let's see. So you have 20 people that are going through a baggage check or whatever, and 30% of the time, 0.3 as a probability, a red light goes off and that person gets searched. So R is the number of people who get a red light. Usually we use X. R is fine. So they asked to find the mean and the standard deviation of R. Now, hopefully the mean is really obvious as a formula. It's just like, hey, how many times are you trying it? How many trials are there? And what's the percentage of the time that there's success? And so you just multiply those and you get the number of times you'd expect. So in this case, that would of course just be 20 times 0.3, and that's it. Now, the standard deviation is a simple formula, which is, and I'll use sigma for standard deviation, is the square root of n times p times q. And that would be the square root of 20, of course, times 0.3, of course. And then the number that goes here is the percentage of the time that you fail, which is just 1 minus 0.3. It's the rest of the percentage. So that would be 0.7 here. These two numbers, the p and the q, have to add to 1, or like 100%. This is a good little question. It's asking, find the probability that at most 3 out of 20 people would get a red light. So find the probability at most 3 out of 20 people would get a red light. So what they're really asking for is they're asking for the probability that X is less than or equal to 3. Whoops, not X, right? What were they using? They were using R. Must have been for the number of red lights. So the probability of the number of red lights is at most 3. So the first trick is to realize that when they say at most, that means at most 3. So that means it could be 0, 1, or 2, or 3. So you actually have to find the probability that R is 0, the probability that R is 1, the probability that R is 2, probability that R is 3, and you add those because it could be any one of those. Yes, silly me. Probabilities. So you add those 4 probabilities and you will find the probability together that it's one of these, that it's at most 3. So it could be any of those. And remember, the way you find this one, so let's say we're talking about the probability that you get 2 red lights, that would be so there's a formula, right? It's n choose k. That's the number of ways you could get 2. And let's write the formula. That will be p to the power of k, which is the probability of success, to the number of successes. And this is the probability of failure. 1 minus p is the same as q, probability of failure, to the number of failures. And the number of failures is n minus k, because the number of trials is the total number of times you did it, and k is the number of successes. So when you take away the number of successes from the total number you tried, you're going to get the number that you failed. And so this is the number of fails. Okay. I don't know. Hopefully labeling like this helps. This is interesting, that is the number of ways that you can get k successes. And so this would be the number of ways you could get 2 successes here, because remember that 2 successes could occur at any of those 20. But I hope you also realize I didn't finish this formula, right? I actually, to do this correctly, this should of course be k, right? And then what you would do is you would then do this for 2, for 3, for 1, and for 0. And the probability for 0 is negligible, which means super small, and it'll basically be 0. But you should show the work and do it. What a terrific question. Sorry if that's loud. What a terrific question this is. So Um, this is basically saying that the probability of being somewhere on a bike path that's 3 miles long, you have an equal probability of randomly finding someone at the beginning as you do at the end. Y represents the distance from the start at the bike path at which a randomly selected accident occurs. So they're basically saying an accident can happen anywhere. It's not more likely that the accident happens here than it is here. Now, this is actually not realistic because on most bike paths there's probably some places where it's much more likely to have an accident. But let's assume it's like a perfectly straight bike path and the chance of having an accident is the same everywhere along the 3 miles. So, jumping right to the question, why is the probability valid? Well, for a probability to be valid, remember that the sum of probabilities must equal 1. And really what that means is that the area under the density curve, so the area under this curve must be 1. And so you have to prove that the area is 1. Well, to prove that the area is 1, just think the area is just as this simple rectangle, right? So it'll be the base of the rectangle, which I sincerely hope that you realize is that 3, right? And the height of the rectangle is right here, and you put that in and you show that the area is 1. And I will let you finish. Now, Aaliyah. Now, this is a silly question in a way because they use this name Aaliyah. Aaliyah's property adjoins, and Aaliyah is the famous R&B singer who tragically died in a plane crash in 2002. If you haven't heard of Aaliyah, she's a terrific artist. And I actually looked up, because what they're saying here is they're saying that Aaliyah's property adjoins a bike path. Why? I don't understand. Maybe I'm wasting your time, but I actually looked up, and Aaliyah, before she died, she had bought a really amazing condo in New York, like really expensive condo, and it's not near a bike path or anything. It's just a fancy condo. Yeah, there's Aaliyah. A fancy condo in New York. And the house that she grew up in is also not near a bike path. This is in Detroit. So the textbook authors, they're silly. Maybe they're Aaliyah fans. Although whatever. Find and interpret the probability that y is between 0.8 and 1.1. So the probability, so here say 0.8, here would of course be 1.1. Find the probability that an accident, y represents the distance that an accident occurs. Find the probability that an accident occurs here. Okay, so of all other spots. So let's do it. What would you do? Well, the probability is just the area. Now, the student who is not, let's actually just write this right here. The student who is not fully understanding this is going to say, oh, I know how to do this. 0.8 to 1.1 is just 0.3 because there's a 0.3 distance there, so that has to be the probability. That's not true. The probability is the area under the curve. So you have to find the area of this rectangle. So you have to see that 0.3 is the base, and then the height is 1/3. And so then you put that in here. This would be 1/3, and there you go. I pretty much did the problem for you. The answer should be a number smaller than 0.3. This question, you can read it. What height must the distribution have? The area must be 1. So 1 has to equal the base times the height. The base is 3, right? 2 to 5. The height, you can figure out what that must be. It's a shame it's the same as the last problem. The textbook, they should have better questions. They should change it. But nope, the height, it's just going to be a decimal or a fraction value. And then you can use that to calculate b. So b is saying the probability that the time is between 2.5 and 4 seconds. So what would you do? Well, that would be the area between 2.5 is right about right here, and 4 would be right about right here. So it would be that area. Base would be, you can figure out the base between between 2.5 and 4, and the height. Hopefully that's easy. These two questions are really important to understand for your learning. Let's do number 5. The probability distribution is shown here. Find the location of the mean and the median. So of these 3 choices, one of them is going to be nothing, and the other 2 will be the mean and the median. So when you're doing these, it's very important to realize that the median, what it does is it divides the area into 2 equal portions. And that's very important. And then the other thing that you want to see is that the mean can be skewed left or right. So the mean is either going to be higher or lower than the median. This graph, because you have a few big values, the fact that you have a few big values, they don't impact the median very much, but they very much impact the mean. So this graph, we would say, is skewed right because of these few big values, and those few big values will raise the mean. So because it's skewed right, we can say that the mean skewed right, let's think, those big values raise the mean, so the mean is greater than the median here. All right, so what would we do next? So to finalize this question, we have to decide what these 3 are. And A cannot be the median because it does not divide them into equal portions. If I cut this in half, this is way too small compared to all of this area is way bigger. Now, the median could be B or C. So A is nothing, and the median could be B or C. Well, the mean is greater than the median, so that means that the median is B and the mean is C, because the mean had to be greater than the median because of the fact that it's skewed right. Hope you can do this one. Very similar. Here, Rafael Nadal, superstar tennis player. This is his first serve speed, and the mean and the points that are 1, 2, and 3 standard deviations from the mean are labeled on the horizontal axis. So what they're basically saying is that there's 7 numbers down here. One of them's the mean, and the other ones are the points that are 1, 2, and 3 standard deviations from the mean. So it says just identify the mean and the standard deviation. So I really hope that you realize this is absolutely the mean, and then this would be 1 standard deviation above, 2 standard deviations, 3 standard deviations, and this is like -1 standard deviation below the mean, and -2 and -3 standard deviations below the mean. They just said to identify. Very good. I like these classic problems. This is a really good preparation for calculus, a really good connection to calculus. This is a probability distribution of a random variable x. So it's just a math problem, but related to statistics, based on statistics. Show that the probability distribution is valid. So what they're really asking for is to show that the sum of probabilities is 1. To show that the sum of probabilities is 1 means to show that the area is 1. So you have to show the area of this is 1. You know, you could slice this into a rectangle and a triangle. That's one way to do it. You could also break it right here and have a trapezoid and then this rectangle here and show the total area is 1. So that's what they're asking you to do on that first problem, is just show the total area of all of this area comes out to be 1. Okay, now let's continue. Problem 2, find the probability that x is between 0 and 0.2. So they're asking for really what's the area of this area, right? How much area is that? It's going to be less than 1. It's going to be less than 0.5. Just visually, we know it's less than half. So how would we find that area? Well, it's just really a simple geometry problem. The easiest is probably to slice it right here and to say we have an area of a triangle plus the area of a rectangle and just add those two together. And so that would look like base times height for the rectangle and then plus 1/2 base times height for the triangle. And the base of the rectangle is 0.2 and also the base of the triangle is 0.2. Now the height here, you have to think what's this value, and because this is linear and this is the straight line I'm saying, and it goes down from 2 to 1 between 0 and 0.4, and 0.2 is absolutely in the halfway mark, then it is safe to assume that that will be at a height of 1.5. So then you can think, okay, hey, this is easy. Now I know what that height is going to be, and I can find that height of the triangle, which would be a little number, and then the height of the rectangle, well, that's just staring at you right there. This last question C, or actually this is part D, huh? This question C says, why is the median between 0.2 and 0.4? So somewhere here is, somewhere right around here or something is the median. Well, how do you know where a median is? Remember, a median is the halfway point on a ranking list, so it divides the whole population into two equal portions. And that means that the area on one side has to be equal to the area on the other side. And if we put it at 0.4, the area to the right would be too small. And if we put it at 0.2, well, your work from part B will show you that 0.2, this should come out to be less than half, right? This area here is less than half. So this is less than half, and then, 0.4 also is not balanced either. So that means the balancing point has to be in the middle. I'd like you to write a simple sentence that summarizes that idea. Now D, is the mean of X less than, equal to, or greater than the median of Y? I do believe the answer here is that there's kind of a downward sloping nature. So for that reason, these bigger values out here that compared to the rest of the group that's more over here, these few bigger values will kind of skew. This is kind of skewed right. Definitely it's skewed right more than left. So that means that hey, I'll let you think about that. Look above for that question. If it's skewed right, that means these few big values are gonna pump up the mean. I kind of told you the answer. All right, what's going on here? Mean weight of a potato chip bag is 9.12. Standard deviation of the bags is 0.05 ounces. This is ounces. And use this rule, about 68% of the results are within one standard deviation, 95% are within two standard deviations, and 99.7 results are within 3 standard deviations of the mean. So when they tell you this, you should really be thinking, hey, is that a whole number of standard deviations? It is a whole number of standard deviations. How many standard deviations is it away from the mean? It is 2 standard deviations away from the mean. Well, let's actually calculate it and see. So we take the mean minus 9.12 and minus the x value, and we're going to get 0.10. We could even turn this into a z-score. The x value minus the mean divided by the standard deviation. And hey, it's 10 cents away. Or 0.10 of an ounce away. Each standard deviation is 0.05 of an ounce. So just divide this and you'll see 2. And what that really means is that 9.02 is 2 standard deviations below the mean. Remember, z is the number of standard deviations a value is from the mean. So a simple chart might, or I should say a simple density curve or a simple normal curve, both of those words work because this is a density curve, and specifically it's the density curve of a normal distribution. This density curve, just drawing it might help us, right? So here is 9.12 the mean. This would be 1 standard deviation below. This would be 2 standard deviations below, 9.02. And now, let's use the rule. So 1 standard deviation, 2 standard, this would be 9.22. Not that we really need it, but what we know is we know that wait. Let's think this is 2 standard deviations, so 95. It should be 95.5, so 955, close to 95. Very similar, right? It really depends on the textbook. They say it's a rule, but some textbooks just use 0.95, some use 955. either way I will accept, and I will be very clear on our quizzes. For this, let's just go with 955. So 95.5%, 0.955 are within this range. They're asking, what's the probability that x is less than 9.02? So they're really asking you, what is the probability of being in this little area here? Well, realize this little area and then this little area over here, these two are equal, right? They have to be, because this whole normal curve is symmetric. So the total area is 1. So the strategy you got to start realizing is that to do part A, you're going to say that the probability of x being less than 9.02 would be the probability of being in the green region, and the little green region would be half of the remaining percentage. So 1 minus 0.955 would be the total for both of these little areas right here, and then we would divide that by 2 to find just the green percentage. 1 is like 100%, and 0.95 is like 95%. So we just subtract that, which would be 0.045 divided by 2, and that would be 0.0225, which is basically a 2.25% chance of being in this green region. Problem A is done. Let's look at problem B. Problem B. Find the probability the bag weighs between 8.97 and 9.1. So they want us to use the rule, right? They want us to use this rule. So these two values, well, they better have given us whole standard deviations, and I think they did. Let's see what's going on. So 8.97, how many standard deviations away is that? Well, the mean is 9.12 minus 8.97, that is 0.15. Each standard deviation is 0.05. So that means that this value is minus 3 standard deviations below the mean. And this is for the same reason. Oh, wait a second, that's only plus 1 standard deviation. So we need to think. Let's think. So they want us to find the probability that the result is somewhere between 8.97 and 9.17, which is minus 3 standard deviations and plus 1 standard deviation. So this is kind of an interesting question, because it's actually much easier to answer by just using the standard normal table, which is right here, right? And it's actually much easier to do this way, but we'll do what they want here. So I've been thinking for the last few seconds, and I think the easiest way to do this problem is to kind of slice it right here and find the area of this part and then add it with the area over here. You could try to subtract this area from 1 and also subtract this little area also from 1, and the remaining would be this total. But we want this total. So basically what we're going to do is we're going to add this green and we're going to add this purple. So what the green is the green is half of the probability of being within 1 standard deviation. So this right here is the probability of being within 1 standard deviation. That whole black area, how much is that? Being within 1 standard deviation is 0.68. So the green area is going to be half of that 0.68. So what we have is you have 0.68 divided by 2. That is the green area. And now we want the purple area. Now the purple area is half of this area, right? All the way up to plus 3 standard deviations. Now this entire black area is the area that represents within 3 standard deviations, which is 99.7% or 0.997. So we want half of that. So the purple area is going to be 0.997, but half of that. And then we're going to take this value and add it. I'll let you finish. That's going to be the total area, which will be the probability of being between these two values. This is a good little question. You know, it's so similar to the previous question. I'm not going to take time in the video. Sorry. I'm actually not sure what the last part captured, but I was basically explaining that this is the answer to part A. Hopefully the video caught that. I might have been on pause and I might not have been recording. Okay, I had the numbers wrong here a moment ago and now I'm fixing it just because I didn't properly add 30. 170 plus 30 is 200, plus another 30 is 230, and then of course this is 260. And now this question is asking, what is the probability that the x value is between 200 and 230? So that is asking, let's get a good color here, that is asking what is the probability of being in this magenta region. So let's erase this. That's the mean, obviously 170 is the mean, and we want to know what's that magenta probability. Well, how could we do this? So what we could do is we could say, basically, if we can find what I will do, call this mark it as like a horizontal space. If we can find that probability of being within this, between the mean and 230, and then what we could then do is subtract this more pink area, which would be just the area between 170 and 200. So the pink area is going to be half of one standard deviation's width. So the probability of being within one standard deviation between 140 and 200 is 0.68. So this pink or red area is 0.68, but divided by 2, which is of course 0.34. Now, I'll do in this overlapping green, this whole green that I'm over highlighting, that is half of being within 2 standard deviations. So actually it's a little deceptive to have this line baby blue. The baby blue should be symmetric. So there's 2 standard deviations. That matches. And then let me put a green line here. There's a green line. Okay, so the red area is half of 68, which will be 0.34. Now this green area, which goes all the way over here, is half of 2 standard deviations. So the baby blue line represents 2 standard deviations. Well, 2 standard deviations is 0.955. And okay, so this whole green area is half of that. So that would be 0.955 divided by 2, which is let's see. I should be able to just do this. .4775, of course. Now, I hope you know what's happening. What do we want? Well, we actually just want this little magenta area that's hiding behind the green area. So what are we going to do? We're going to say that we're going to subtract this. So we could say the answer here, if you want to write the full answer, would be the probability. Why is that so big? The probability of being 200 to 230 would be the whole green area, so 0.955 divided by 2 minus 0.68 divided by 2, and you take 0.4775 minus 0.34, and that would be your answer. These questions, I really have a complaint with the book because it doesn't ask you exactly what to do. It just says, find the 25th percentile. Well, what about it? Well, what they really mean is find the z-score for the 25th percentile. And so kind of if you really wanted to write this out. So they're asking what's the z-score of the 25th percentile, what's the z-score of the 75th percentile. If you really wanted to write this out, the way you would show the work for this is you could say the probability of z being less than a certain value comes out to be 0.25. What is that z-score? So I hope you're realizing that we're going to turn right to the standard normal table, and we're going to find 0.25, and we're going to find the z-score. So 0.25. These are all the positive values, so these are all 0.5 and larger. We want 0.25. What's that z value? So 0.25 is right about right here. So what is that value which is right about right here? What is that? That is negative 0.06, 60, 61, 62, 63, 64, 65. So right between 64 and 65. Which one is closer? This one is actually a little closer if you look at the hundredths or the thousandths and the 10,000ths place carefully. So this value here would be negative 0.64, and so z equals negative 0.64 for the 25th percentile. For the 75th percentile, you would do it exactly the same way. Oh, glad I caught this. That should be a negative. Okay, and you know, cool thing about 12 is that it's the same thing, and they want the first and last decile, so that means find the 10th and the 90th percentile. So you just use the table backwards again, and you find a z-score, and you find a z-score. Oh my goodness, this video is already like 30 minutes long. You know, here, this is actually, to me, the trickiest problem in this entire packet. Trickier than even the problems at the very end. Problems at the very end are actually just applying what we've been learning in class. This is a little strange, and you really have to connect the ideas. So remember an outlier. An outlier is something that is greater than or equal to the quartile 3 plus 1.5 times the IQR. And the IQR is the distance between the third quartile, Q3, and the first quartile, Q1. Now, from our previous problem, it's actually kind of cool how these problems connected together a little bit, is that the 25th percentile, the z-score was negative 0.64. The 75th percentile will, of course, be 0.64 because it's symmetric and it's on the positive side, or the greater than the mean side. So what we're really going to do is we're going to say, when you're at this boundary line for an outlier, so this boundary line for an outlier is probably going to be, let me get this purple, it's probably going to be somewhere way up here, right? And so they're basically saying that's going to be Q3 plus 1.5 times the IQR. And they're basically asking, what is this percent? What is the, what percent of values are larger than, what percent of values are outliers? So we're going to have to creatively use the table and really apply our understanding. So let's start by finding the IQR. Now, the IQR is usually expressed as x values, but we can actually use z values. You can't use percentiles. You can't just add and subtract percentiles, but you can add and subtract z-scores, just like you can add and subtract x values, because really z is just a number of standard deviations. So this is like 0.64 of a standard deviation minus 0.64 of a standard deviation. How many standard deviations up here is this thing going to be, this outlier, which is just Q3 plus 1.5 times the IQR. So Q3, let's find the outlier as a z-score. So the z-score boundary for the outlier, how interesting, right? So that z is going to be Q3, which is a z-score of 0.64, plus 1.5 times the IQR, and the IQR is the distance between these two. So if you wanted to really get fancy, not fancy, but I should say thorough, it's actually simple. The IQR is the distance between these two, and the way you find the distance is you subtract the right minus the left. So that would be 0.64 minus negative 0.64, which is 1.28. So the IQR, the interquartile range, is 1.28. Now we're going to find the z-score. And the z-score, this is too much at one time. What are we talking about? The outlier is going to be 0.64 plus 1.5 times 1.28. So the z-score for the outlier, which is Q3 plus 1.5 times the IQR, the z-score boundary for the outlier is 2.56. How interesting. So way back, I dropped my pen. I got excited over how these problems connect together from first semester. So this came out to be 2.56. So what percentage of values are larger than 2.56? Well, to do this problem and show the work, you really can only look up values that are less than a z-score on the table. So we're going to do that. And actually, here, I'm going to do a different way. So what we want is the probability that z is greater than 2.56, which will be 1 minus the probability that it's less than 2.56, because this is going to be a big number. The probability that z is less than this big number, which is going to be most values, and we want this little area over here. So all we simply do is we turn to our normal table, and we get the we look for the z-score of 2.56, which would be 2.5, 50, 51, 52, 53, 54, 56. There you go, 0.9946. So this would be 1 minus 0.9946, which is 0.0054, which is approximately 0.5%, which is about half of 1%. So about half of 1% of values are outliers in a normal distribution. Fascinating. Nothing else can compare to the excitement of that previous problem. This is a straightforward problem. Blood pressure, mean 70, standard deviation 20. Find the probability that x is less than 80. So you don't have to draw a normal distribution every time, but it might help. 70, and one standard deviation above will be 90 because the standard deviation is 20. One below will be 50. We're looking for the probability of being at 80 or lower. So the probability of x being less than 80 is equal to the probability. What we do is we convert this to a z-score. And so we find the z, and they just want less than. But actually in these less than and equal than this is actually the same thing, because these lines are infinitely thin. So the thickness of the line doesn't matter when you're calculating these probabilities. So it actually doesn't matter if you put this or this. Oh, whatever. We'll stay consistent with the problem. So the probability of x being less than 80, we just got to find a z-score. So the z-score is going to be, well, hey, what do? It's x minus the mean. So the x value is 80, minus the mean is 70, divided by the standard deviation is 20. So the z-score is 10 over 20, which is 0.5. So this 80 value right here has a z of 0.5. And so what's the probability of being over here? Well, we can just turn directly to the table and find a z-score of 0.5, and that is going to be right here, and boom, there is your answer, 0.6915. Believe it or not. So the probability of z being less than 0.5 is that decimal that we just looked up. This problem is the same as the previous problem, except it's the probability that x is greater than a given x value. So read the problem, there's the mean, there's the standard deviation. The way you're going to do this is you're going to do it the same way, but in the end, you're going to subtract from 1. So please realize that you have to subtract from 1 after you look up the z-score, because the z-score is the percentage of values to the left, and this problem is asking for the probability of being to the right. So convert this to a z-score, look up the probability, and subtract from 1. Now, we've actually done quite a few of these in class. This is using the knowledge from the previous problem where the mean milligrams of sodium is 2,000. I don't feel like putting units right now. And the standard deviation is, what was that? That was 500. So this is Chipotle meals are very salty is the conclusion. So what's the probability that you actually have like a lower salt? It's actually a high salt meal, but for Chipotle, it's lower than their typical meals, even though it's still high salt, so high sodium. So we want the probability of x being between 1200 and 1800. So you have to convert both of these to z-scores. And what's going on is, so here's 2000, here's 1800, here's 1200. We're looking for the probability of being in this range, right? So what are we going to do? We're going to convert this 1800 to a z-value. We're going to convert this 1800 to also a z-value, and we're going to say, okay, with those z-values, what's the probability of being, just look up the table. We're going to go to the table, look up this probability, all that orange. Now you only want the purple. So the purple is going to mean find this probability by looking up this z-score, not 1200, convert it, and then find the z-score for 1200. And that will be this little blue probability. And so find the orange probability, which is the z-score for 1800, and find the blue probability, which is from the z-score of 1200. And those probabilities are on your normal table. So yep, and once you find those two probabilities, you subtract them, and the subtraction of the probability from this one and the probability of this one, subtracting those will give you the probability of being, will give you the area, right, of this purple, which is what you want, which is the probability. This problem is exactly the same. So here they're saying find the 60th percentile, and so what they're really asking of first class letter weights, so they're asking what is the x value? So what is a weight of a letter at the 60th percentile? And I hope these values are accurate. That would kind of be interesting. I feel like they are. So you have to go backwards and find the x. So we're looking at this type of little calculation for z. We know standard deviation. We know the mean. We're looking for the x, so we're going to put x. But the z-score, well, we should know the z-score. The z-score is coming from the 60th percentile. So what is the z-score for the 60th percentile? So in this case, we just kind of have to use the table backwards. And so that means that we're going to look for 0.60 inside here. Where is 0.60? Oh, we're pretty close already. Right about right here. And that value is 0.26. All right. So the z-score, so when the 60th percentile as a percentile, that z-score is 0.26. Easy money now. Actually, now what we can just do is we can just take this thing right here and we can say, look, we know the z-value. The z-value is 0.26. And now, the 60th percentile is a z-score of 0.26. It's slightly above the mean, right? Not a whole standard deviation above, just a little bit above the mean. And so you're going to solve for x, and hey, you should get an x value that's like 0.7 something. 0.7, slightly higher than this. The first step is to multiply both sides by 0.16 to eliminate this, and then you multiply these, and then you would add 0.69, and you'll get your x value of a letter. And the x value represents the weight of a letter at the 60th percentile. Cool problem. Here on this one, very similar. The smallest and largest 5% of head sizes get custom-made helmets. War, what is it good for? Absolutely nothing. Classic song. Now, alright, so these folks over here get custom-made helmets, and these folks over here, and this is 5%, so 0.05, and this is also 0.05. So I hope you're already thinking what it's asking for. What head sizes get custom-made helmets? So we're looking for two x values, the smaller x value and the larger x value. So what is this x value and this x value that get custom helmets? So what is the percentile right here? This percentile mean what percentage is less than the 5% at the top? Well, that percentile would have to be 0.95, because that's just, subtract 0.05. And this percentile is, of course, 0.05. And so these are percentiles. Those are percentages. We can look backwards and find z-scores and then solve for each one, and it'll be very similar. So you're going to look for 0.95 on the standard normal table, and you're going to find the z-score, and then you're going to find the x value for that z-score, and you're going to do the same, for the 0.05. So 0.95. That's right about right here. Right here, inside here. So that is 1.6061626364. These are actually equally close. So whatever, we'll just choose one. 0.64 is close enough. So here, the z-score equals 1.64. Hey, I hope you realize it's symmetric, negative 1.64. So to find the x value, that's what we're looking for, right? So how do we do that for those small and large head sizes where 5% of the largest 5%? What is that x value? Well, it's easy money now. You could say z equals x minus the mean. We're looking for x. We know the mean, 22.8. And the standard deviation is 1.1, and we know our first z-score, or I should say our larger z-score, is 1.64. And you would just multiply both sides by 1.1 and add 22.8, and there's your x value for the larger head size, and you do the same for negative 1.64. This problem, baby birth weight. The mean is 366 grams. That's like 3.6 kilos. And babies who weigh less than 2,500 are considered low birth weight. Yeah, that's just like 2 kilos, 2.5 kilos. So let's see. Standard deviation, 511. These numbers are just a distraction, but kind of interesting actually that this is actually real data, and they give even some reference you can find at the end of the textbook from Norway. I think they have an advanced healthcare system, free healthcare for all. I mean, all Western European countries have free healthcare. Very unique in the United States to not have that. But anyway, what percentage of babies will be classified as low birth weight? So pretty much what we're looking for is just the probability that X is less than 2,500. So this is a straightforward problem. There's your X value. Here is your mean. Here is your standard deviation. Plug those in. Find the z-score. Look up the z-score and find its probability. And its probability will be to the left, which is actually just what we're looking for. In here, find the first and third quartiles, so of the birth rate distribution. So they're really asking, what is the x value at the 25th percentile, and also what's the x value at the 75th percentile? So what they're really saying here is that the probability is 0.75. So P is 0.75. So 75% of babies are lower than what birth rate? So you go on to your table and you find 0.75 and 0.95. We're going to find 0.75. So we're looking in the middle, which is right about right here. Oh, it's some value over there. So about probably 0.68. I hate it when I have to go all the way over here. 0.75 is 0.6. This is a little closer, so 0.67. This is 0.6. If I scroll back to the left, that's 0.6. Oh, you can see it there. 0.67. All right. So 0.67 is the z-score. So when the percentile is 0.75, the z-score for that percentile is 0.67, meaning meaning that 0.67 of a standard deviation above the mean is where the 75th percentile is. Once you know the z-score, you can set it equal to x minus the mean divided by the standard deviation and solve for x. Solve for x. And then do the same thing here. There'll be a lot of symmetry here because I do believe that this z-score should just be the negative because of how z-scores are beautifully symmetric. This is a great little problem. Put a bigger lid on it. They put these silly titles. What a cheesy thing. I don't see those in college textbooks. It's kind of insulting to give a cheesy title on every problem. What a waste of printer ink. Anyway, maybe not. Maybe it gives a little flavor. There's always different perspectives. Enough chit chat. So this problem, kind of my bad for not including exercise 7. You have to reference back in the book exercise 7. But basically, a lid that's too small is a lid that is smaller than 3.95. And they want to reduce the percentage so that the percentage of lids are 1% or less. So the percentage of lids that are too small. So how many lids are too small when you squeeze them on? The manufacturer wants almost all lids to fit. Only 1% can be too small. Because if more than 1% are too small, companies will send back lids. So let's actually do the problem. If the standard deviation remains 0.02 of an inch, so they're manufacturing, standard deviation is 0.02 of an inch, at what value should the mean be so that only 1% or less, they don't say or less, but that's pretty clear, I hope, right? Because it has to be 1% or less, not 1% or more. So that only 1% or less are going to fit, are too small to fit. So what that means is that 1% or less are less than 3.95. So, and they're asking at what value should you set the mean? So they're asking what is the mean? Whoops. They're asking what is the mean value that will make this happen? So we're looking for this. Well, what do we know? We know that the probability that x is less than 3.95 has to come out to be 0.01. Okay? So that's the probability. Could we find the z-score? Could we turn this into a z-score and say the probability that z is less than a certain value is 0.01? Right? So yes, we're going to convert this 0.01 to a z-score. And so now, of course, we just turn to our table and we look for 0.01%. And so 1% would be way in the negative z-scores, which would be 0.01 is finally right about right here. Maybe it's actually over here. No. Oh wait, here, silly me. There's the best one, which is negative 2.33. So negative 2.33. So when the 1 percentile of lids are smaller than this number of centimeters, this is centimeters, right? Yeah, it must be. I didn't say it, but it must be from the previous problem. Is small, or maybe it could be inches. No, 4 inches? Yeah, 4, no, that's inches. Actually, that's inches. 3.9 centimeters. No way. That's a large cup, too. Yeah, it has to be inches. Okay, sorry, too much chit-chat. Z is less than or equal to negative 2.33. It has to be equal to 0.01%. Ah, there's our Z value. We're done with this 1 percentile. So basically, we say 1% of lids means the z-score is negative 2.33. What are we looking for? We're looking for the mean. I think we can just calculate the mean backwards and say, look, use this formula, z equals x minus the mean divided by the standard deviation. So when we use that formula, z, negative 2.33, so meaning 2.3 standard deviations below the mean, is our x value, 3.95, minus the mean we're looking for, divided by that same old standard deviation. What does that mean have to be so that this works out the way that only 1% of lids are smaller than this size? Well, now you just solve. And the key thing to here is to just realize all you have to do is solve this equation. And solving this equation is as easy as multiplying by 0.02 on both sides, and then subtracting 3.95, and that'll be a negative u, and then just multiply both sides by -1 or divide by -1 to find the mean, the mu. So yep, that's how you would finish that problem, and you would solve for the mean. I really hope that this has been helpful as we've gone through all these problems. Have a great day and good luck, and please send me a message if you have a question. Whew, that was kind of a bit.